Hi guys, 2020 relative velocity. Two stray cars move move along one road towards the intersection at a uniform speed of 6. So this one's moving 6 and the other one's moving 8. Find the velocity of B relative to A. Alright, let's do PBA. Alright, velocity of A. Everybody happy with 6 to the right? 6 to the right would be 6i. This one's going up at 8. Opposite alternate angle would make that 30. So this is 8 cos 30 and this is 8 sin 30, which is 4 and 4 root 3 respectively. So PB is 4 root 3i and then plus 4j. Everybody with me so far? That's what you just got, was it? Hopefully. Alright, next one. Velocity of B relative to A, BBA, is top one, BB take away VA. So it's going to be 4 root 3 take away 6i plus 4j. Right? Now if we might as well just consult Mr. Marking Scheme while we're here. And so far I'm on 15 marks. So that's pretty sweet. Alright? So 15 marks so far. Alright. So A reaches the intersection 5 seconds before B. Alright, and find the distance each car. Alright. Just about. Alright. It doesn't actually give you any distance, which makes it different than other questions we've done. Everything we did in the book always had an initial distance away from the junction, didn't it? So I decided to throw in a bit of a curveball here to make you think. So you're on 15 marks out of 30 at the moment, and here's what that's the only piece of distance information they gave you. Okay? But this isn't so bad because we can actually piece one or two, we can do something with that. Alright? So we put A at the junction. A is here. Okay? And then we say, how far is B away? Anybody? B is 5 seconds away. Does everybody agree with that? B is 5 seconds away. And here's the good news about this, okay? A is here, B is here. Okay? And what's 5 times 8? 5 times 8, anybody? 40 meters. Everybody cool with that? Now, what have you guys learned from me? We don't do it like this, do we? Yes? Huh? Oh, is B 6 or 8? B's 8. And A reaches the intersection 5 seconds before B. So B is 8 multiplied by 5 seconds. B is 40 meters out. Does everyone agree with that, or did I get it wrong? Are we good with that? Alright, hopefully. Now, here's what I'm thinking. I've never cut an angle of. I'm gonna evaluate PBA just to tell you what I'm dealing with here before we make any rash decisions. All right. So PBA, would everybody agree? It's 4 root 3 minus 6 across, and it's 4 going upwards. And I'll Pythagoras theorem that to get its speed. The velocity of B relative to A. Okay. So open 4 root 3 minus 6 squared plus 4 squared. That gives me 16.86 as the speed of B relative to A. Yeah. Oh, did I not square it? Oh no, thank you. Root answer 4.1. that what you got?
Yeah.
4.106, great. Right, 4.106. Now, I also need to figure out this angle. So I'm going to tan inverse. I'm in radians, so I need to sort that out. Angle unit, degree, shift, tan inverse 4 divided by 4 root 3. Take away your 6. And we got 76 point, I'll go 76.936. I don't like it when it's dead center and you round up too much, so I'll go to 3 decimals in cases like that. 76.936. So angle A is 76.936. Now think about it, alright? We know this angle's 30, don't we? You ever agree that's 30? Yeah? What angle is B moving relative to A? What angle is B moving relative to A? So what does that mean? I can just angle this up, can't I? I'll use a different colour. I can just angle this up at what angle? Yeah, I think this might actually work out easy enough. I'm hoping it does. Alright, so what angle does that make this little part in here then? 76 take away your 30. I'll do it the other way in a minute, just so you have more weapons. So what angle would that be? 46.936. Alright, and it's the whole point of the question trying to figure out the distance. Oh no. Find the distance each car is from the intersection when they are nearest to each other. Alright. Do I need to find the closest distance? No. I need to find how long it takes B to get to the closest distance. Everybody cool with that? So I have to find out how long it takes B to move to the position of the closest distance. So which line am I actually after here then? So after that yellow one, haven't I? So how do I find the yellow one? Right, Mick?
Well, I just look at the marking scheme. For some reason it says the GA is 30.
Now, okay, lads. Okay. So, I'm going to have to find out this yellow distance here. So what did we say? What do you think it is? We go for cos. Cos 46.936 is your hypotenuse, which is 40. And we call this distance x. Is that okay? And then what does x be? 40 cos that angle there. So 40 cos 46.936. 27.313. 27.313. Right? That's my distance. Now what's my time? Sorry, what's my speed I'm travelling that distance at? I'm travelling at 4.106. So time is 4.10. Oh, sorry, not time. Speed was 4.106. So the time is 21.313 divided by 4.016. Is that right? So, get the time here. Divide that by 4.106. 6.65 seconds. Okay. So it takes 6.65 seconds for that to the closest approach to actually happen. Is that right? So here's what we're going to say. 6.65 seconds. Alright. So I'm going to take that time there. T equals 6.65. And here's what I'm going to do. I'm going to bring it back up here. And the good news is, I'm going to bring it back to its initial diagram. And get rid of all this nonsense for a minute. Alright. What happens to A? What direction is A going in? A is travelling away from the junction. at speed of 6. So if I multiply 6 by 6.65, I should have my answer for A. And my answer for A is 39.9 meters, I hope. Right? My answer for B is it's going to travel to the junction and out the other side, isn't it? So it's going to be 6.65 times 8. But then we're going to have to take away 40 meters because it travels above 40 meters, and then you take away the 40 after that. So it's 8 times 6.65. Take away your 40. And we get 13.2. And here's the part where I look like a mug. You know, go to the marking scheme and check if I'm right or wrong. Ah, lads, like a glove. Right, now I'm going to show you another way of doing it. Okay, this is my first time seeing this question. Right, so another way of doing it, the way I traditionally would have shown you guys what to do was we never bother with the slanted stuff, do we? So here's what I think we would have done differently from what I taught you in class. Alright, so I'm just showing you, sometimes you need to be adaptable. That is a perfectly valid way. It's considered a bit more difficult. Okay, now here's what I'm going to do. I'm going to stop us all the way back here. Is that okay with you guys? How far away is B from the junction again? And 5 seconds away. So here's what I'm going to do. I'm going to advance the full question 5 seconds. I think this is what Mick was talking about earlier. Who's at the junction now? B. Okay. And how far has A travelled in that time? 30 meters. A has travelled 30 meters. Okay. Distance of B to A is 30. The direction I'm going is that 76-degree business, isn't it? Okay. And I want to find the time it takes B to give me the closest approach. So how far does B actually need to move for the closest approach to A to occur? Once again, I'm after the yellow length, which is that length there. So I'm just going to do cosine. So it's going to be cos. Now, in this question, I'm lucky. Do you remember sometimes when you advance it forward, the closest approach has already happened? In this case, it hasn't happened. Alright, so in that case, I think it worked out alright for us, alright? But in the case, that other method might have been easier had it already happened. So you gotta be flexible in your approach. Now we call this x over 30. And then it's 30 cos, that's 76 business there, so 30 cos 76.936. That's 6.78 meters. Is that alright? Oh, sorry, seconds.
No, you divide it by 4.1.
Oh, we do. Thank you, Mick. That's the distance covered, isn't it? So 6.78 meters is the distance B travelled to get close to A. And then, as Mick says, divided by 4.106 to get the time. So this divided by 4.106, and you get a time of 1 point. I got a time of 6.65 last time. What's the difference?
5 seconds.
This one's 5 seconds in there. I started 5 seconds. I brought B to the junction, so that extra 5 seconds disappeared, didn't it? Now I'm at the position where all I need to do is, it's 30 meters for A, 30 meters plus the extra 1.65 seconds at 6 meters per second. B is currently at the junction, so it's just 1.65 multiplied by 8. And we already got those two numbers, didn't we? What are they again, Mick?
39.9 meters per
13.2, is it?
Yeah.
And there you go. It didn't matter which method we used, it was going to work out. Is that alright? I'm just going to stop.